Dear students, this is the sixth lecture on finite differences. Here we will take some more examples which are based on finite differences. Here we have a problem. Prove that del square upon e to the power x into e to the power x upon del square e to the power x is equal to e to the power x. Here this del is a forward difference operator, this e is a shift operator, okay, which we have already discussed about shift operator and forward operator in my earlier classes, and you can watch all these videos. Here we have a left hand side is equal to del square upon e to the power x into e to the power x upon del square e to the power x. Okay, here we know that del is a forward difference operator, and also we know that del of fx is equal to f of x plus h minus fx, and e is a shift operator, that is e fx is equal to f of x plus h. Okay, means if we have e minus 1 fx, means this is equal to f of x minus h. Okay, now we have left hand side, that is, now we can write here e inverse, and this is del square e to the power x. Okay, here we can apply this property, e fx is equal to f of x plus h, where h is the interval of differencing, that is this is equal to e to the power x plus h, and this is upon del square e to the power x. Okay, in my earlier videos we have proved that del n e to the power x, what we have proved that del n e to the power x is equal to e to the power x e minus 1 whole square, e minus 1 to the power n, del n e to the power x, del n e to the power x equal to e to the power x and e minus 1 to the power n. Okay, here interval of differencing was unity. If interval of differencing is h, in that case we get here e to the power h minus 1 term. Okay, we know that del n e to the power x is equal to e to the power x and e to the power h minus 1 to the power n. Here h is the interval of differencing. If it is not given, sometimes it is interval of differencing being 1, unity. If it is not given, then we always assume interval of differencing being h. Okay, now from this relation, that is E inverse del square e to the power x. Del square e to the power x means what we can write here? Here we can write here e to the power x and e to the power h minus 1 whole square. Okay. Here we have n equal to 2 into e to the power x plus h upon e to the power x into e to the power h minus 1 whole square. Okay. Now we apply the property of shift operator, that is here e to the power h minus 1 whole square is the common term. E to the power h minus 1 whole square is the constant term, and here also e to the power h minus 1 whole square is a constant term. We can keep outside, and here we have E inverse e to the power x, and here we have e to the power x plus h upon e to the power x. This term we keep here. That is, now these two are cancelled out, and e is by the property of e minus x fx, fx minus s means this is equal to e to the power x minus h, and here we have e to the power x plus h, and in denominator we have e to the power x, that is e to the power x minus h plus x plus h upon e to the power x. Now these two cancel out, that is e to the power 2x into e to the power minus x, that is e to the power 2x minus x, and this is equal to e to the power x, that is right hand side. Okay, in this way we can solve this problem. Now we will take another example. Now next problem is evaluate del square five x plus 12 upon x square plus 5x plus 6, where interval of being unity, where interval of differencing being unity. Now we have to solve this problem. What we have to solve? This is del square and 5x plus 2 upon x square plus 5x plus 6. Here this del is a forward difference operator. Okay, and definition of this del is del fx del fx is equal to f of x plus h minus fx. But here h is equal to 1. Here interval of differencing is 1. Okay. First we factorize this term, that is del square, and here we have 5x plus 12, and what are the factors of these two? X square plus 5x plus 6, that is x square plus 2x plus 3x plus 6. What we get here? Del square 5x plus 12 upon, here x is the common term, x plus 2, and here 3 is the common to x plus 2. X plus 2 is common, that is x plus 2 into x plus 3. Okay. Now we apply, this is an improper fraction. First we try to convert this fraction into a proper fractions by applying partial fractions. Okay. Now we split up this improper fraction in a proper fraction by using partial fractions. Okay. Now suppose this is the equation number 1. Now we apply partial fraction. By applying partial fractions. That is 5x plus 12 upon x plus 2, x plus 3 is equal to a upon x plus 2 plus p upon x plus 3. All we have idea about partial fractions. Now we have to find out constant values of these two constant a and b. That is 5x plus 12 upon x plus 2, x plus 3 is equal to a, x plus 3 plus b, x plus 2, and here LCM term is x plus 2 and x plus 3. Now these two are cancel out. Now when we put x equal to minus 2 here, means this term will be 0. What we get? We get a is equal to, when we put x equal to minus 2, means we have minus 10 plus 12. Okay. X equal to minus 2, here we have a and here we have 0. That is a is equal to 2. When we put x equal to minus 3 both the side, means 5 into minus 3 plus 12 is equal to, this term will be 0, and here we have x equal to minus 3 minus 2 minus 1, minus 3 plus 2, that is minus 1. On solving, b is equal to plus 3. That is, from this equation we can write the value of, that is, from this relation we have 5x plus 12 upon x plus 2, x plus 3 is equal to 2 upon x plus 2 plus 3 upon x plus 3. Okay. Now from equation 1, from 1, that is del square five x plus 12 upon x square plus 5x plus 6 is equal to del square. Here we can write in place of this 2 upon x plus 2 plus 3 upon, this is x plus 2 and plus 3 upon x plus 3, that is del, this del into 2 upon x plus 2 plus 3 upon x plus 3. Okay, that is now first term 2 upon x plus del fx f of x plus h minus fx. Okay, this is the forward difference operator, and del fx f of x plus h minus fx means what we have here, del 2 is the common term, we can keep outside this 2, and this is 1 upon x plus interval of differencing is what 1, means we have x plus 3 minus, by using this formula del fx is equal to f of x plus h minus fx, where h equal to 1, f of x plus 1 minus fx, we put x equal to x plus 1. We have here x plus 3 minus 1 upon x plus 2 plus 3 times 1 upon x plus 4 minus 1 upon x plus 3. Okay, now solving, simplifying this, that is del it is 2 times 2 is the common term, yeah, or we can put this 2 here, okay, or here suppose, and what we have in numerator, here we have x plus 2 x plus 3 is the LCM term, x plus 2 x plus 3, this is LCM. We have here x plus 2 minus x minus 3 plus 3 times x plus 4 and x plus 3, this is LCM, x plus 3 minus x minus 4. Okay, that is, now these two are cancel out, okay, these two are also cancel out. Now we can separate this, we have minus 2 minus 3 is minus 1, that is minus 2 del of 1 upon x plus 2 into x plus 3 plus 3, here we have minus term, means minus 3 del 1 upon x plus 3 and x plus 4, x plus 3 and x plus 4. Okay. Now applying this forward operator, that is minus 2 f of del fx, f of x plus h minus fx. Again applying the forward difference formula. The f of x plus h minus fx, and here h equal to 1. What we get here? 1 upon x plus h, x plus 3, x plus 4 minus 1 upon x plus 1, that is x plus 4, sorry, x plus 2 and x plus 3 minus 3 into 1 upon x plus 4, x plus 5 minus 1 upon x plus 3 and x plus 4. Okay, that is now solving this, what we can do here, minus 2 what is the LCM of this? X plus 2, x plus 3, x plus 4. Okay, on divide and multiply this term by x plus 2, x plus 2 upon x plus 2, x plus 3 and x plus 4 minus x plus 4 upon x plus 2, x plus 3 and x plus 4 minus 3 into divide and multiply by x plus 3 in first term, that is x plus 3, x plus 4, x plus 5, and here divide and multiply by x plus 5, that is x plus 3, x plus 4 and x plus 5. Means minus 2. Here LCM is x plus 2, x plus 3, x plus 4 in first term, and in numerator we have x plus 2 minus x minus 4 and minus 3. Here LCM is, in second term we have LCM x plus 3, x plus 4, x plus 5, and that is we have x plus 3 minus x minus 5. Okay, that is these two cancel out, these two cancel out. What we have here, this is 2 minus 2, 4, that is minus 2. Here we have 4 upon, what is our first term, x plus 2 x plus 3 and x plus 4, and here we have 3 minus 5 is minus 2, minus 2 into minus 3 plus 6, that is 6 upon x plus 3 x plus 4 and x plus 5. Okay, here we have to simplify this. Now we can multiply here x plus 5 multiply and divide by x plus 5, and here we put x plus 5, and here we multiply and divide by x plus 2, and here we can put x plus 2. Now what is the common of these two terms? LCM of these two terms, that is x plus 2, x plus 3, x plus 4, and x plus 5. Here we have 4x plus 20 plus 6x plus 12. That is, on solving this, finally we have 10x plus 32, that is 2 into 5x plus 16 upon x plus 2, x plus 3, x plus 4, and x plus 5. And this is the final answer. And I hope all you have understood this problem. If you have any queries regarding this lecture, then you can comment on comment box. These are the images of my today's lecture. That this is the page number first. You can take screenshot of this, and this is the page number 1. This is the page number of 2, and this is the page number 3. Okay. If you have any doubts regarding this today's lecture, then you can comment on comment box. And if you feel this lecture is helpful for you, or you feel it is useful, then please like and subscribe this channel. Okay. Thank you very much. Have a nice day, and Bharat Mata ki Jai.